Hi, I'm Dave from TRC. Welcome to our Heat Pump Boss series. Level up your heat pump installs. We've got the tools, tips, and how-tos to help make you an expert heat pump installer. Today, we're going to focus on understanding load calculation software. Let's dive right in. Let's talk about the importance of software limitations when performing load calculations. For those who need a refresher on what load calculations are, they're designed to help installers select appropriately sized heat pump equipment. The goal of load calculations is to avoid rules of thumbs and instead find equipment that best matches the unique features of the space. Inaccuracies at the start of the process result in inaccurate load calculations, even if the software does the math correctly. This is often referred to as garbage in, garbage out. For further review, we do a deeper dive into load calculations and why they are important in video 1 of this series. To perform load calculations, contractors use load calculation software. While these tools are incredibly powerful, it's important to recognize that they come with their own limitations and biases. A helpful way to think about it is that the software tools are a lot like power tools. They can help you get work done quicker, but if you don't pay attention to the fundamentals, they will just cause you more problems later. For instance, load estimating software tools use defaults that don't always match a building's materials or features. Every software product has built-in defaults, and those defaults can significantly affect the results. Some softwares may not have updated values for newer technologies, which can lead to inaccuracies. And if Manual J software isn't used correctly, it can produce misleading or inaccurate answers. This is why the person performing the load calculations has a responsibility to study the ACCA Manual J and software thoroughly. Understanding the software you're using and applying it attentively is critical to ensuring accurate results. By being mindful of these limitations, you can make better decisions, avoid costly mistakes, and earn your customers' loyalty by delivering the best service and equipment. There are a variety of software options available for performing load calculations, and understanding the software of your choice is a big piece of the puzzle. Both paid and free tools are available. Some for purchase options include MyTech RightSoft RightJ, CarmelSoft HVAC ResLoad J, and Elite Software RHVAC, all of which are ACCA approved. More free options include ACCA Manual J spreadsheets, CoolCalc Manual J software, and Better Built NW HVAC sizing tool. There's no shortage of options, and each has its own strengths and weaknesses. Now, let's look at some of those limitations in more detail. While these tools are incredibly helpful, they're not without their challenges. One common issue is the limited ability to adjust preset R values and U values. For example, contractors often have to change the wall thickness just to get closer to the actual R values, which can be frustrating. Similarly, the material selection and R value modeling option are often limited. This makes it harder to get truly accurate load calculations for new homes built to current or future codes. Another challenge comes from auto-generated construction features, like windows, walls, roofs, and floors. The default option in the software usually do not match the building exactly. If these features aren't reviewed or adjusted by the contractor, they can lead to inaccurate results. The same goes for the map trace feature. While it's a convenient tool, it can result in incorrect sizing if the contractor doesn't double-check it against actual measurements. Copying from existing library files without updating them with site-specific data also presents an issue. This can create inaccurate load calculations that don't reflect the actual conditions of the home. And even with carefully entered inputs, some software tools are known to generate higher loads compared to others, which can lead to oversizing. These limitations highlight the importance of using load calculation software carefully and attentively. It's not just about relying on the tool. It's about understanding its nuances and double-checking the results to ensure accuracy. Let's explore an example that shows how different software tools can produce different results, even when using the same inputs. Here's a scenario using a real home, putting its data into two different software platforms regularly used in the industry. Critically, both software A and software B use identical inputs for outdoor and indoor temperatures, square footage, and U factors for walls, windows, and ceilings. However, there's a slight difference in the total area for windows. These small variations can lead to differences in the final load calculation results. Now let's take a closer look at the additional inputs. Here, we see factors like floor area, floor U factor, leakage category, and appliance loads. While most of the inputs are identical, there's a small difference in the appliance load, 2000 BTUH in software A versus 2400 BTUH in software B. There's also a minor discrepancy in the duct's total heating load. These small differences, combined with how each software handles defaults, assumptions, and calculations, can add up to significant variations in the final outputs. Let's look at the final results. Software A calculates a heating load around 33,000 BTUH, while software B comes in at about 40,000 BTUH. That's a difference of nearly 7,000 BTUH. For the total cooling loads, the differences are opposite. Software A calculates a higher total cooling load around 21,500 BTUH, while software B is around 19,000 BTUH. This shows that even with similar inputs, different software tools can produce results different enough to impact what heat pump you would choose to install. This is why it's so important to carefully review your inputs, understand how each software processes data, and choose your tools wisely. Knowing the limitations of your software can make all the difference in achieving accurate and reliable load calculations. Here are some common pitfalls to be aware of when performing load calculations, so be sure to check for them. Start by verifying that the homeowner's name and address information are accurate. Make sure the outdoor design conditions are based on ACCA Manual J, Table 1A, unless local codes specifies otherwise. For heating, use the 99% outdoor dry bulb temperature, and for cooling, use the 1% outdoor dry bulb temperature. For reference, all the 99% dry bulb temperature means is it's colder than this only 1% of the hours in a year. Similarly, 1% dry bulb temperature means it's hotter than this only 1% of the hours in a year. We use the 99% heating design temperature to ensure the system can meet demand during nearly all cold conditions. The 1% cooling design temperatures decides the system for typical peak heat while avoiding oversizing that would reduce efficiency and humidity control. Also check the indoor design conditions to confirm they're consistent. Heating set to 70 degrees Fahrenheit, cooling set to 75 degrees Fahrenheit, and relative humidity at 45%, 50%, or 55%. We're using these conditions because they represent typical, comfortable indoor conditions that allow accurate load calculations without assuming unrealistic set points. Pay attention to the balance of heating load versus cooling load. In colder climates like New York, the cooling load should typically be between 1/2 to 1/3 the heating load. Additionally, a good rule of thumb is that the conditioned square footage is within plus or minus 10% of what's listed on real estate websites like Zillow or Redfin, or government building data websites. The home should match online listings closely unless there was a recent addition or renovation. Last, confirm the number of stories in the home to ensure calculations align with actual structure. In addition, here's some quick checks to be aware of. First, ensure there are no loads included for adiabatic surfaces, such as floors, ceilings, or walls between two conditioned spaces. These surfaces don't contribute to the load and should not be factored into the calculation. Double check that the wall surface areas are accurate by multiplying the perimeter lengths by the average ceiling heights, which are typically between 8 to 10 feet. Also, verify that the ceiling area and floor area are consistent. Keep in mind that sloped ceilings will have a greater area than the floor area, so adjust accordingly. For ductless heat pump systems, confirm that no duct losses are included. Also, for ducts inside the thermal envelope, make sure there's no duct losses. Additionally, ensure that the building's air tightness is reasonable. For new construction, the design heating ACHN should be a maximum of 0.3, while for existing buildings, it should be a maximum of 0.7. Ventilation inputs should also be reasonable, typically between 30 to 100 CFM for residential buildings. According to Standard 62.2-2016, homes should receive 0.35 air changes per hour, but not less than 15 cubic feet of air per minute per person. Homes that meet their air change needs with infiltration through the building shell should have no load for this category. Kitchen, bath, and other ventilation that only runs occasionally should not be included in the ventilation load. Finally, confirm the accuracy of all assembly inputs and U factors. This includes above-grade and below-grade wall assemblies, ceiling assemblies, and floor assemblies. Don't forget to verify window inputs as well, including glass type, U factor, SHGC, emissivity, overhang, and shading. These details are critical to ensuring accurate and reliable load calculations. Some homes include features that make load calculations more challenging, things like overhangs, rounded walls, or full siding walls. These features aren't necessarily rare. They show up in remodels, custom builds, and modern designs, and when they're present, they need to be captured accurately in your Manual J. Some load calculation programs do have options tucked away in the menus to help you model these uncommon details. Don't hesitate to explore the software. Check the advanced inputs, or click the Help buttons. Help buttons can often explain how to enter features like these. At the same time, keep in mind that not every software platform can model every architectural detail correctly, or even at all. When that happens, use your judgment and follow best practices to approximate the impact without overstating or understating the load. The key is simple. When the home has an unusual feature, don't ignore it. Capture as much detail as you can, enter it accurately, and use the tools in the software to get as close as possible to real-world conditions. Once you've captured all the building features, you can use this chart as a guide for what a typical load looks like. These displayed ranges give you a quick reasonableness check. Just remember, loads vary depending upon climate and construction details. These are a quick way to make sure your numbers make sense before you move on. But a thorough Manual J is the only way to be sure you are modeling the building accurately. Thanks for diving in with us on understanding load calculation software. Remember, we're here for you at cleanheatconnect.ny.gov with more videos, resources, guides, and best practices. Hope to see you in our other sessions as we complete better installations together, one project at a time.